Need a new. Okay, hi there. I'm back. My name is Wilfrid, and I'm a senior math tutor, and I'll be covering 10 questions of pre-algebra today. A little bit backstory. I just recently graduated from MAC with a major in biochemistry and a minor in mathematics. And if you have any other questions, please submit them through OneClass. But I'll be going through 10 questions today. So let's start. Okay, cool. So the first question we have it says, how to simplify the root of 3 minus 1 over 1 plus the root of 3. So when we're simplifying, what it means is that the question is asking us to reduce this into a form with less radicals and without the the fraction too. So how do we simplify this? Well, we're going to use a concept called a conjugate. And what a conjugate basically is that we basically flip. So it's a term. So let's say that we have x plus y as one of our terms, okay? The conjugate of that would just be flipping the middle sign from positive to negative, or negative to positive. So the conjugate of x plus y would be x minus y. And the really useful thing about a conjugate is that it helps to reduce and to simplify the denominator, which is very hard to do normally. And by doing so, we can come up with a simplified term for this, I guess, more complex term, as we can say. So let's try to simplify it, okay? So we have root 3 minus 1 over 1 plus root 3. So the conjugate of the denominator of 1 plus root 3 is 1 minus root 3. So basically, a very clever technique is that we're going to multiply this term by 1, okay? So we know that whenever we multiply anything by 1, it's the same term. However, we can also say that this 1 is can be expressed as in this form. So we can say 1 can be expressed as 1 minus root 3 over 1 minus root 3. So you see here that this still equals 1, but we have cleverly changed the 1 to make it the conjugate on the numerator and the denominator. Now, if we expand this term out, what do we get? So at the top, we get root 3 times 1 is root 3. Root 3 times negative root 3 is 3. Negative 1 times 1 is negative 1. And negative 1 times negative root 3 is positive root 3. What about the bottom? So if we multiply the conjugate to this term at the bottom, we get 1. 1 times negative root 3 is negative root 3. Root 3 times 1 is root 3, positive root 3. And root 3 times negative root 3 is negative 3. We can see here that our radical terms cancel out. And now all we're left with is the top, so I'm going to simplify this too, is 2 over root 3 minus 4 over minus 2. Okay? So by multiplying the denominator by its conjugate, we have now simplified this term where there's no radical at the bottom anymore. And now all we need to do is we're going to reduce. So we can see here that we can divide the top, this 2 times root 3 and negative 4, divide by negative 2. So we're going to do that. We get negative root 3 and plus 2. So this is a simplified version of this complex term, I guess you can say. So now we have found our simplified version. So looking at what the junior tutor wrote, they basically wrote the same thing. The only thing is that the denominator of the expression is actually 1 plus root 3, not 1 minus root 3. So that's where they put something else there. So, yep, so this solution is correct. Cool. All right. Yeah. So let's move on to the next question. Question number 2. Alright, so question number 2 reads, how do you find the vertex of a quadratic equation or function? Okay, so as we all know, the quadratic function follows this format. Okay, so a times x squared plus or minus b times x plus or minus c. Okay, where a, b, and c are constants. Okay, so the vertex of a quadratic function, I think I covered this last time, but I'm going to do it again. Let me just, sorry. So the vertex of a quadratic function depends on which orientation the quadratic function is facing. So you can either have a downward facing quadratic function or upward facing quadratic function. So if you have a downward facing quadratic function, like, let's say like this, your vertex is going to be your maximum, your highest point. Okay. If you have a upward facing quadratic function like this, then your vertex is going to be the minimum, or the lowest point. Okay. So both this and this are vertices. I'm going to write vertex. Okay. So it can either be the max or the minimum, depending on the orientation of your parabola. Now, there are 2 ways to solve this question. For one, you can graph out your quadratic function and you can visually find your vertex, or you can use this very simple equation to find the x-coordinate of your vertex, and then you can find your y-coordinate. So the x-coordinate of your vertex is given by the equation negative b over 2a. Okay, so it's going to be the coefficient b divided by 2 times the coefficient of a, and you make it negative. And all you really need to do to find your y-coordinate for your vertex is to sub that and to sub this x-coordinate back into your function. So that is how you find the vertex. So either you can do it visually by graphing it out and looking at the graph, or you can use this equation. Either way works. And so the junior tutor provided the mathematical computational way of finding it, and this solution is correct. Let's see this answer. Cool. All right, let's move on to question number 3. Alright, so how do you factor x cubed plus 8? Alright, so we're going to use what we call a law called the sum of cubes law, I guess, or rule or property. And the sum of cubes property basically tells us how to factor a term that has 2 cubes in it. So let me explain. So let's say that we have a cubed plus b cubed. Okay, it also can be a cubed minus b cubed, and there's a different I guess, rule for that, or property. So a cubed plus b cubed, if you want to factor it, there's a very neat trick where it's actually, these are the 2 factors for it, which is going to be a plus b times a squared minus ab minus, plus b squared. Okay. So this is the sum of cubes rule. It states that any sum of cubes can be factored into this form. So if you had the difference of cubes, I guess you can say, then the factoring would be a minus b times a squared plus ab plus b squared. So this is sum of cubes, and this is difference of cubes. Okay. Cool. So when we're talking about factoring x cubed plus 8, we're going to need to use our sum of cubes rule. Okay. So x cubed plus 8. That's x cubed plus 8 can be alternatively written as x cubed plus 2 cubed. And this is now our sum of cubes rule. So now if we factor it, we have x plus 2 because it's a and this is b, and this is x squared minus 2x plus 4. So these are the factors for x cubed plus 8. All right. Let me just check the math here actually before I do anything. So let's expand this actually. So it's x cubed minus 2x squared plus 4x plus 2x squared minus 4x plus 8. Did I do that right? Yes, I did. So this cancels out, this cancels out, this cancels out, this cancels out. So we get x cubed plus 8. Cool. And the reason why I expanded it is because the junior tutor solution is actually incorrect here. They added extra 2, which they shouldn't have, because now if you expand this, you have extra term. So this solution is partially correct. You added an extra 2 in one of your factors to the second term. Alright, so solution is incorrect. Okay, cool. Let's move on. Question number 4. So what is the length of AB round to the nearest tenth? So they also included a diagram here. So this is a right angle triangle with sides A, B, and C. And they also included an angle of the triangle and also the length of AC. So we're going to use our trigonomic properties. Since this is a right angle triangle, we can use cosine, sine, and tangent to our advantage here. So let's say that this 75 degrees at ACB, let's say that this is equals to theta, okay? And theta equals 75 degrees. So now we know that the cosine of theta and the sine theta and tan theta are related to the ratios of certain sides. For example, cosine theta is the relationship of side AC, or the adjacent, over AB. Sine theta would be side BC over AB, or the hypotenuse. And finally, tan theta would be opposite over adjacent, which would be BC over AC. Okay, so we're going to use our cosine theta because we're given the side of the adjacent angle, and we're going to need to find AB. Okay, so we know cosine theta, so it's cosine of 75 degrees equals 10 over AB. So now side AB, or the hypotenuse, would be 10 over cosine of 75. And we're going to calculate that using our calculator here. Okay. Oops, sorry. Let me just turn this back. Okay, so 10 divided by cosine of 75 is going to be 38.637. Okay, so 38.637 meters. Remember that the side AC is in meters, so we're going to use their units, meters. And they also ask us to round to the nearest tenth, so we have a tenth, a hundredth, a thousandth. So we're going to round to the first decimal point. And since the 100th point is not equal to 5 or greater, we're not going to round up. So all we have is 38.6 meters. So side AB is 38.6 meters. Cool. So that's the solution to the problem. We figured out that this is a right angle triangle, so we can use cosine, sine, and tangents. By utilizing that, we were able to use the cosine function, to use the angle and the appropriate side to find our hypotenuse. And once we find our hypotenuse, we round it up to the nearest tenth, which is 38.6. The solution is correct. Nice work. Cool. All right, let's move on to question number 5. All right, so how do you find the inverse of y equals ln x? So let me talk about inverse functions for a second, okay? So we know that our function, let's say f of x. So function f of x, basically what that does is, okay, so we'll have a pool of x values, okay? So these are our x values, okay? So it takes one of our x values, and then we punch it through f of x to get a bunch of f of x values, okay? So let's say f of x equals y, which equals something else, okay? So we'll make it distinct here. So we have a bunch of y values, okay? So what the inverse function does is that it reverses what the f of x function does. It takes values of y and brings it back and maps it back to a value of x, okay? So we write, the convention is to write an inverse but after the f, like this. So inverse of f of x will take a value of y and map it back to a value of x. Okay, so when they're asking us to find the inverse of y equal ln x, there's a technique that we can use, okay? So the technique is that we want to swap x and y, the places of x and y. So if our original function was y ln of x, to solve for the inverse, we're going to first of all swap x and y. So now we have x equals ln y, and now we're going to solve for y. So let's apply the natural Euler's number to both sides, or Euler's number, I guess. So e to the x equals e ln y, and we know because of our property of ln that this equals 1. So now all we're given is y equals ex, and we're going to write it in its convention, f of inverse 1, f of inverse x equals e of x. So now we have found the inverse function of our original function, which is e to the x. So this is what the junior tutor did, and this is the correct solution. So they swapped places with x and y. They applied Euler's number to both sides. They used the property of Euler's number and ln to simplify the right side, and all they're left with is y equals ex, and then they found their inverse function. So this is the correct solution. Good work. Cool. All right. Moving on to question number 6. So question number 6 reads, what is a unit matrix? So the junior tutor wrote, a unit matrix is any matrix with n by n dimensions containing elements in the main diagonal with values of 1 and the remaining elements as 0. So there's a few things to know about a unit matrix. First of all, it has to be a square matrix, okay? So unit matrices are never not square matrices. And what a square matrix essentially is that this matrix has the same number of rows and columns. Okay, so for example, a 2 by 2 square matrix would suggest that we have A, B, C, D, right? So we have the same number of rows and same number of columns. A 3 by 3 matrix would be A, B, C, D, E, D, E, F, G, H, I. So this is a square matrix that's 3 by 3. So that's the first property of unit matrices, okay? That they have to be square matrix. Second of all, it says that the main diagonal of these square matrices are 1 and all the other values are 0. So a unit matrix, let's say a unit matrix that is 2 by 2 would be 1, 1. So that's the main diagonal, 0, 0. So that's what a unit matrix looks like. And these unit matrices are very important, and they have a very special property. So a while back, I covered matrix multiplication. And the thing is that when you multiply a matrix, let's say matrix A, but with a unit matrix, let's say matrix I, we actually just get A back. So anytime a unit matrix is multiplied by a matrix, you just get the original matrix. And there's other different properties about unit matrices that are very important, but they all stem from this, I guess, proof or fact. Okay, so the junior tutor provided us with some examples of unit matrices. So the one needs to be on the diagonal, and it needs to be a square matrix, because without a square matrix, there's no main diagonal. So this solution is correct. Cool. All right, so how do you convert log 329 to a natural logarithm? So the natural logarithm is ln, and it has base of Euler's number. So how do we convert this random logarithm to the natural logarithm? Well, there's a very interesting property with logarithms called the change of base. And it suggests that the log of base b with argument a can be converted to a different base by this formula. So let's say that we want to convert it to base c, for example, then we would just need to do this. So we have log base c of a at the top and log base c of b at the bottom. So this is how you convert your first logarithm to a different logarithm. It can be base 10 to base 8, base 9 to base 27. It could be base 10 or base 3 to ln, right? This is the formula for doing that. Okay, cool. So let's try to change log 3 to ln. Okay, so log 3 base 20, log base 3 of 29. If we use the formula here, we want to use ln of. So we take the argument and we put it at the top. So ln of 29. And then we take the base of the original logarithm and we put it at the bottom. So this is our change of base, and we've now transformed log base 3 of 29 to a natural logarithm, which is the division of ln 29 divided by ln of 3. So this number is going to be represented in a natural logarithm, or we can calculate it out into an actual number. So this is what the junior tutor wrote too. They used a change of base formula. They stated what the natural logarithm was, and then they used a change of base formula to calculate this term in terms of ln. So they did a base change. Okay, cool. All right, question number 8. How do you factor the expression x squared minus 5x minus 6? So we're going to use our cross multiplication method to factor this. And basically what it means to factor it is to find the associated terms that contributes, or when you multiply them together, will make x squared minus 5x minus 6. So I've covered this before, but the cross multiplication rule states that we find factors of our first and third term, we cross multiply them together, and then we add those terms together. If we get the middle term, then we have found our factors. So the factors of x squared are x and x. It can also be negative x and negative x, but we're going to use x and x. And the factors for 6 could be 1 and 6 or 3 and 2. In this case, I'm going to use negative 6 and 1. So these contribute to equal negative 6, and these contribute to equal x squared. So if we cross multiply these together and add them together, what do we get? So it's negative 6x plus x, we get negative 5x. So now we have found our factors, which is x plus 1 and x minus 6. And therefore, x squared minus 5x minus 6 equals x plus 1 and x minus 6. Alright, so the junior tutor didn't really provide a understandable solution to this. They just said, think of a number that when added, the sum is negative 5, and when multiplied, the product is negative 6. Since when added, 1 minus 6 equals negative 5, and when multiplied, 1 is negative 6 equals negative 6. This is not really actually a solution to the problem, so this is the incorrect solution. Consider using the cross multiplication method. So they didn't really provide a tangible solution to this problem. Right? Cool. Moving on. Question number 9. How do you write 6 over 10 in the simplest form? So to simplify a fraction, we have to basically consider the factors of the numerator and the denominator and see where there are common factors. If there are common factors between the numerator and the denominator, we can simplify or reduce them out of the fraction. Okay? So let's think of the factors of 6 first. Okay, let's think of the factors of 6. We have 1 and we have 6, right? What else do we have? We have 2 and 3. So those are the factors of 6. What about the factors of 10? We have 1 and 10 and 2 and 5. Okay, so where are the similar factors here? Well, there's only one, which is 2 and 2. So that means in our fraction here, we can cancel out 2 and 2. So this equals 3 times 2, and this equals 5 times 2. Cancel these out, and we have reduced our fraction, 3 over 5. So 6 over 10 is equivalent to 3 over 5. So that's how you write it in the simplest form. And the junior tutor definitely got this correct. They found the factors of 6 and 10. They found that there's a common factor of 2. They canceled it out, and they're left with the most reduced form, which you cannot simplify anymore. So that's the simplest form. Cool. All right, finally, last question. Complete the table by finding the logarithmic and exponential forms of the given expressions. So before we even begin, we want to find the relation between the logarithmic form and the exponential form. So let's say that we have log base b of argument x, which equals, let's say, y. Okay, so what's its relation to the exponential form? So let's say this is the logarithmic form. So what's its relation to the exponential form? So basically what a logarithm does is that it takes a base and it takes the output and it spits out the exponent that would make that base to the power of the exponent, the output. So basically, in exponential form, this will look like this. B to the power of y equals x. So that's the relation between the logarithmic form and the exponential form. Okay? So in the exponential form, we're taking base b to the power of y to equal x. The logarithmic function is trying to find the exponent that will take base b to make it to equal x. Okay? So now let's look at our chart here. So our first logarithmic form is log 8. Whoops. Log with base 8 with argument 8 equals 1. Okay? So what's the exponential form to that? Well, we have our base of 8. We have our exponent of 1. So 8 to the power of 1 equals 8. Cool. Next, what about log of 8 64, 2. So we see here that the answer to log base 8 of 64 equals 2 because 8 squared equals 64. So the exponential form would be 8 squared equals 64. Cool. All right, let's go back the other way. So now we have 8 to the power of 2 over 3 equals 4. So we see that 8 with a root of 3 and squared equals 4. Well, the logarithmic expression for this is our argument, this is our base, and this is our answer, right? So log of 8, which is our base, argument of 4 equals 2 over 3. Cool. Okay, next one. 8 to the power of 3 equals 512. Well, that would just be log of base 8, argument of 512, equals 3. Cool. Let's go the other way around, except this time we're going to be using negative numbers. So log of base 8 of 1 over 8 equals negative 1. That's the equivalent to saying in exponential form, 8 to the power of negative 1 equals 1 over 8. Finally, we're going to do the other way around here. So we have 8 to the power of negative 2 of 1 over 64. That would equal our base of 8, 1 over 64 equals negative 2. So that is completing the chart of converting logarithmic forms to exponential form. And the junior tutor goes through step by step for each solution here, and they also give us a definition of a logarithm and the relation between a logarithm and the exponential form. So this solution is correct. Nice work. All right, so today was a little bit of a shorter stream, but I covered a lot of simple questions surrounding the basics around logarithms, around factoring, and we also covered what conjugates are, and we covered a little bit about unit matrices today. So if any other questions or any questions with your homework, please submit them through OneClass, and we'll try to get through them with you guys. But other than that, thank you for listening, and I hope you guys have a good night.